Hello, my name is David. Thank you all for coming. I make robots, and I'm going to talk about what's happening over there today, briefly. Yeah, here we go. I'm going to start more or less chronologically. Some of these videos are early, so they're not the best quality, but I think it gives you an idea of kind of where I'm coming from and where I'm at now. Uh, One of the first robotic devices I made is this one titled infrared drawing device. And as you can see, well, I initially wanted this to be kind of a surveillance situation where it would track people as they went throughout the room. But as you can see from the video, it really kind of turned into an unruly child, or kind of a highly specialized drawing instrument or mark-making device there. Tracking me as I move my hands in front of it. So very simple use of an input and an output. So from there, I was invited to participate in an exhibition at this place called Laboral in Gijón, like the north coast of Spain. And I decided to take that idea of the drawing devices and extend it across the Atlantic Ocean in this case. So here we have a remote sonar drawing device done in 2008. And what we have is a drawing arm, much like you just saw, and a sensor array. In this case, it's a sonar sensor, which can detect people or objects into a space about 3 meters. And we have a drawing arm and a sensor array set up in the US at the University of Minnesota, where I teach. And then we have a drawing arm and a sensor array set up in Spain. So the drawing arm in Spain would produce drawings based on the data collected in the US and vice versa. So they were these very gestural drawings done from a great distance away. And as you can see, the drawings are, they are what they are. They're very expressive, I suppose. But it really kind of turned into this strange communication, like this kind of call and response system where you could interact with the sensor array and it would produce drawings in the US and then vice versa. So you really didn't know what you were doing on the other side. There was no like video tracking it. It was only the machine and the array. So from there, I started to think about maybe integrating more natural phenomena into the work. And I live, I'll show you a map in a minute, but I live on Lake Superior, which is 10% of the Earth's fresh water. It's a lake, a sea, but it's an inland sea, so it's very much like an ocean. You can't see the other side of it. It's a whole lot of water. And I took a ferry across that lake one time in 2009 and took my older Mac laptop with me that had an accelerometer in it. And that accelerometer, I hacked into it and managed to get the data as the ferry moved up and down all the way across that lake. And I output it to this kinetic sculpture here. So Z is the amount of displacement that the wave moves up and down, and then the delay between each one of the motors is the period of the wave. And it was quite a rough day on the lake that day. And these are just hobby servos making the movement up above, and you can see it's very much like a marionette. So this was my journey across the largest lake by surface area in the world. So taking that idea further, I was thinking, well, wouldn't it be cool to put a sensor on the surface of the water, and make it like waterproof and cellular and batteries and all this stuff where it could transmit uh, data back, water surface data back to an installation in the gallery. And I was trying to figure out, how do I make it waterproof and what kind of cellular connection and what kind of sensor and how's it going to last out on the water. And a friend of mine told me about this National Oceanographic and Atmospheric Administration. It's in the US, NOAA for short. And they've already done it. They've already done that, and they've done a way better job than I could ever do. They have buoys all over the surface of the oceans, on the Atlantic, on the Pacific Ocean. And from these buoys, you can get wind speed, water temperature, but you can also get wave height and wave period. So I decided to use one of their buoys for this installation. So this is a much larger scale version of the wave, and it's using a buoy that's in the central Pacific Ocean, and it was installed in Marseille in France in 2013. So this is what's happening in the middle of the Pacific Ocean, recreated in the gallery space in France. Same sort of principle, so the amount of distance, the amount of height of the wave is the amount of distance that the motor moves up and down, and the delay between each one of the motors is the wave period, is mapped to the wave period data. So it changes day to day. You come back to the gallery and maybe it's big waves, and then the next day it might be smaller, just based on what the current conditions are. So I was commissioned to do this installation for Interior Biennale, actually just west of here in Kortrijk in Belgium in 2013 also. And I wanted to do something similar, but maybe make it a little bit more complex. So in this case, I used a hacked Microsoft Connect, which if any of you worked with that before, you know that it puts out or it makes a very elaborate point cloud of surfaces. So I set one of those up above the water near Lake Superior and collected the water surface data with a pool cover, actually, because the Kinect doesn't bounce off of water very well, so the pool cover allows it to bounce off of something plastic. And then the data from the Kinect was mapped to the 750 individual servo motors for the grid structure here. And there's the point cloud. So it's like 250,000 points, but then I scaled it to 729 individual points, which I think still gave me a fair amount of complexity. And it was oriented above the viewer's head. So as you enter the gallery space, you're walking underneath the surface of the water. So taking that Kinect, the image from it is pretty cool on its own. So I made a waterproof container for the Microsoft Kinect camera and then mounted it in a very natural area, I suppose, with trees. And then the point cloud data was sent to the gallery space. So kind of recreating, and it's very, as you can see, it's very fuzzy. It's a very imperfect image. And I think of these pieces as, in a lot of ways, kind of this failure to capture natural phenomena, but maybe in some ways making something unique or something, not an exact replica, obviously. So this video was running in the gallery space as the camera was mounted in a remote location. So this is, there we go. This is where I'm from. So that's Lake Superior there, and then I live in Duluth, a little ways north of Minneapolis, you can see there. So the ferry I took was all the way across this lake here. And I decided to make a project that was also connected to the lake, where I deployed a drone to a specific spot over the lake. The exact same location, the exact same GPS location, and the exact same altitude, but on different days in different conditions. And the drone had a camera mounted to it that would look downward at the surface of the water. So I deployed it in different conditions and took an image of the surface of the water, and then using some software converted that image into a height map or a bump map, which then can be converted over to a three-dimensional model that I generated a toolpath for, and then used to carve into acrylic, into plastic, using a CNC machine. And so I carved the surface of the water collected by that drone into several different acrylic cylinders on different days in different conditions. So you have this fixed moment, this very dynamic, fluid, moving surface of the water fixed. And so each carving was a little bit different based on whatever the conditions were on that particular day and time. And so there's a collection of 5, and you can see how the conditions very much differ from day to day. Something's happening over there. Here we have, is it a robot coming to get me? Here we have a piano that's played by the clouds. So I have a camera that's outside that's pointed at the sky. So as the clouds go past, the video is captured. Then I take that video and I chop it into 88 individual pieces, each piece corresponding to a key of the piano. So if it's very intense white over a particular key, that key is pressed very hard. If it's a little light, then it's kind of just barely touched. So the clouds are producing this the sound. I don't think of it as music as much as a sound piece. And it can be quite boring if the sky is blue on a particular day, or quite obnoxious if it's a storm. Here we're tracking some space debris. So this installation tracks the oldest pieces of human-made space debris currently orbiting the Earth. So stuff as far back as 1957 is still orbiting, like rocket bodies or defunct satellites. So all of these twigs are pointing in the direction of those 5 oldest pieces of space debris as they orbit. So they're not only over our head, but as the objects are beneath us, the twigs are all pointing in that direction. And so here's a time lapse. So the piece in the exhibition, Telepresent Wind, if you haven't seen it, it's in the high school, the Notre Dame High School around the corner there, and it's in the gymnasium. So if you'd like to go check it out and see what's happening over there, you can go see the piece. It was a project that was started in 2010. The first time I displayed it was in a place called Laboratoria Art and Science Space in Moscow. And I set up the sensor in the U.S. in Minnesota, and at the base of the sensor is an accelerometer. So basically, it's measuring tilt as the plant stock is being blown around by the wind, and then data from that accelerometer is sent in real time to, in this case, the 50 devices in the gallery space. So they're all moving in unison based on that accelerometer data. So it's a super simple system. So the version in the gallery space here in the mirror is 3 times larger, so it kind of amplifies the effect. So they're all using the exact same data. There is a slight pause between the groupings. So if the wind hits one side first, those move first. But they're all essentially doing the same thing. But they behave in subtly different ways because of differences in the plant stocks. The motors are, not perfect. So they all each have their own kind of personality, I guess. So the last thing I would like to show today is a project that I'm currently working on titled The Other Side, kind of a working title at this point. But I'm using satellite imagery data, and I'm setting it up so that I capture an image of the other side of the Earth from where the installation will be located. In this case, in Minnesota, where I'm experimenting with it in my studio. So this is Australia-ish right here, and this is the southern Indian Ocean and the southern ocean right here. So I'm basically taking from this spot right here. And I have custom software that goes to this website every 24 hours and will capture whatever the current conditions are, mostly of the clouds, some sea, but whatever the current conditions are captured. And you can see it, obviously it changes pretty dynamically from day to day. And so I'll crop that. Again, the software will crop, this is all kind of an automated system that will crop that into a small square. And then I'm using the same software to convert that over into a height map or bump map that then can be converted over to a three-dimensional model. And from that 3D model, I'm generating a tool path. The system is generating a tool path. I should say this is all automated. I've kind of coded the thing to do its thing, and then I'm trying to step back, as I do with most of these pieces, try to set it up and allow the outcome to do what it does. So from there, I'm generating a tool path, and I actually have a CNC machine hanging from the ceiling currently in my studio. So it's upside down. So it's sort of a reflection of what is happening on the other side of the world. And this CNC machine will then carve whatever that cloud surface, cloud/ocean surface is, creating a three-dimensional model. And so you can see how it varies from day to day. So these are kind of some screenshots of that activity there. And there it is in progress, carving into this foam, which is very tactile. And I'm wondering if this, I don't know, it's still evolving, but I'm wondering if this might turn into something where people can touch the other side of the Earth. But I think it's important that it circulates every 24 hours so that it's a new carving every day. But I'm not exactly sure how it's going to be displayed yet. Yeah, that's what I do. That's all I got. So, thank you.